Hi students, in previous video we discussed searching techniques, especially linear search. In this video we will discuss what is binary search technique and why should we go to this binary search. As linear search is already available, then why should we go through this binary search technique? So let us first discuss what is a limitation of linear search. Then it is easy to understand the binary search. Limitation here it is, so it will take more time to search. It will take more time to search for the particular element. Generally, the time complexity of linear search is order of n, which is linear. That means if you are having 1, 2 and so on, 100 elements are there. Now I want to search, for example, 100th element 100 is present or not. So then how many comparisons we will get? 100 comparisons we will get. In 100th comparison you are getting this element. That means more time to search for the element. To overcome that limitation, binary search is used. To overcome that limitation, binary search is used. Now what is binary search? See, binary means 2. Why the name binary search? Why the name includes here 2? Means here your array, suppose this is an array, your array is divided into 2 halves. So this is called as left sub array. This is called as left sub array. And this is called as right sub array. That means in linear search, for example, this is the array. Now we are comparing with the 0th position, 1st position, 2nd position, 3rd position, like that. Sequentially we will search. So that's why that linear search is also called as sequential search, which is discussed in the previous video. So now, why? I think you understand why we are using this binary search technique. Here, linear search is having some limitation. To overcome that, we are going to use this binary search technique. So now, in this, main array is divided into 2 halves. And the elements should be in sorted order. Remember, to do binary search or to apply binary search technique, the array should be sorted. The elements are present in the increasing order. So based on that we will perform. That may be actually ascending order or descending order. Now we are assuming the elements are in ascending order. Based on that we will apply this binary search technique. So now what shall we do here? The steps for binary search. First, array is divided into 2 halves. Steps here are array is divided into 2 partitions. 2 partitions. Then we will calculate mid position. We will calculate mid position. Actually, based on the mid position only, we will divide the array into 2 partitions. So after dividing array into 2 partitions, next we will compare the element to be searched, that is called as element, or you can say it as a key. Compare that element with mid position element. Mid position element. If equal now, then stop, which is called as a successful search. If not equal, then check whether element is less than mid position element. If element less than mid position element, only search on left sub array. No need to go to right sub array. That means we are skipping some elements. Next, if it is not less than a of mid, then check whether that element may be greater than a of mid. See, here we compared equal or not, and now we are comparing less or not, then greater. If it is not equal, if it is not less, then definitely it is greater. Then what shall we do? then we will search only on the right subarray. That's why here the elements should be in sorted order. This is very, very important. To perform binary search or to apply binary search technique, the elements should be in sorted order. So now let us take an example of a binary search. For example, some elements are there, but these elements are in ascending order. Observe the elements 8, 11, 13, 21, 27, 29, 32. Now I want to search for element 29. Then how can we search? See, by seeing an array, yeah, 29 is present. Here the 29 is present. You can say like that. So now, how can we do? How can we write the logic? This is 0th position, 1st position, 2nd position, 3rd position, 4th, 5th, 6th. That means your array size is 7. Array size is 7. Okay. Now, what is low position? 0. That means what is first step? We will calculate the array into 2 parts based on the mid position. So how can we calculate mid position? Lowest position plus highest position by 2, which is nothing but 3. So first we will compare, this is mid position. First we will compare mid position element and element. Mid position element is 21, which is not equal to 29. If not equal, what we are doing? Whether that element is less than 21. Element is 29, mid position element is 21, is 29 is less than 21. No. Now, next, it is not equal, it is not less, definitely it is greater. 29 greater than 21. Yes, condition is satisfied. If 29 is greater than 21, what does it mean? The elements are present in the, or the element to be searched may present in the right subarray. The element may present in the right subarray. Now, take your right subarray. Right subarray elements here are, what are the right subarray elements? Only these. Right subarray elements are 27, 29, 32. See, we are not at all bothering about these elements. Already we compared and we are not bothering about these elements. We should bother about only right subarray. That's why here linear search will take more time, binary search is taking less time. Okay, now consider this right subarray. Now repeat the process. So 27, what is the position of 27? See, 27 position here it is 4, 4, 5, 6. So now I will write the positions here 4, 5, 6. Now again repeat the process, whatever previously we have done, the same process here also. Repeat that process. So now, for example, now calculate again mid position. Mid equal to, here low position is 4 and high position is 6. 4 plus 6 by 2, 10 by 2, 5, which is nothing but mid. This is mid position. Now what shall we do first? Compare with mid position element only. Mid position is element is 29 and element to be searched is 29. Element is present in the array. In which position? So mid position is nothing but 5. The element present in 5th position. Now let us take another example. Suppose, take another example 2. Now remember the elements should be in sorted order. Okay. Now the elements are 7, 11, 13, 26, 32, 41, 49. These are the elements present in the array. Now I am writing the position 0, 1, 2, 3, 4, 5, 6. Now I want to search for the element 7. Okay. So now how can I search? What is our first step? First step is mid position. Mid position is low position plus high position, 0 plus 6 by 2, which is nothing but 3. So which means this is the mid position, yeah, and this is the left sub array, and this is the right sub array. Now compare first. What we will do, compare with the mid position element. Element is a 7, which is not equal to mid position element. Then check whether 7 is less than 26. Yes, it is. So we will search on the left sub array. Don't bother about this right sub array in this example. So what are left sub array elements? 7, 11. This is my left sub array. 7, 11, 13. Consider left sub array elements. 7, 11, 13. 0 position, first position, second position. Now as usual, calculate mid position. 0 plus 2 by 2, which is nothing but 1. Mid position is 1. Now what shall we do? Compare element with mid position. 7 not equal to 11. Now 7 less than mid position element? Yes, it is not true. It is correct. 7 less than 11. So what shall we do? Now we will bother about, or we will consider only left sub array. Don't consider this right sub array. So now consider left sub array. Only element 7 is there, which is only one element. So 7 equal to 7, which is the element is present in the array, which is called as successful search. Okay, so like that we will perform binary search operation. What is the main logic involved in this binary search technique? What is the main logic? We will first, what shall we do? First we will calculate mid position. How can we calculate mid position? Low plus high by 2. Then what we are doing? We are comparing whether A of mid equal to element. If equal now, then this is the mid position element. If equal, simply printf element is present, and no need to go to the next position. So break. Now this all should repeat, that's why. So up to which condition we will repeat this process until unless your subarray consisting of single element. If it is single element, then that may be the only one element is there, so you can stop the process by comparison. Okay, so now if element is not less, here if it is not less, then it may be, if it is not equal, then it may be less. So check whether element is less than A of mid. If element is less than A of mid, then what shall we do? We will compare only in the left subarray. In the left subarray, see our example. See this. In this example, mid position is 3. Left subarray means lowest index is 0, highest index is mid minus 1. Lowest index is 0. Consider right subarray. Highest index is 6 only. In the right subarray, what is lowest index? Lowest index is mid plus 1. So in the left subarray, what we will do? We will make a high equal to mid minus 1. In the right subarray, we will make low equal to mid plus 1. The same thing here we will write. So now, if element is less than A of mid, we will search in the left subarray. So in the left subarray, what shall we write? So high equal to mid minus 1. If it is not equal and if it is not less, else we will write here. So it is not less, then definitely it is greater, na? Then low equal to mid plus 1. So like that, this you have to repeat. That's why we have considered the loop. This is the main logic involved in this try to implement this program in C or C++ or Python. So try it. If you have any doubt, you can send me a comment whether it is executed or not. Send me. Hope you understand this binary search concept. Thank you, students. Have a good day. Bye bye.